AB Calculus, section 4.3, page 5. We're going to use the second derivative test to find the location of the relative extrema. The second derivative test uses the second derivative to figure out about maxes and mins. So we need to find the first derivative, which is 6x squared minus 18x. And if we factor that, we can pull a 6x out. Leaves us with an x minus 3. Second derivative test, again, uses where the first derivative is equal to 0 only. It doesn't look for undefineds and it doesn't look for does not exist. The second derivative test just uses critical numbers where the derivative is equal to 0. That's going to be at x equals 0 and x equals 3. Once you have those numbers, then you're going to evaluate f double prime at these points. All right, f double prime is just going to do a derivative off of this line right here, which would give us 12x minus 18. And finding f double prime at 0. F double prime at 0 is negative 18. What you're interested in is the sign of that number. That is negative. That means that f is concave down at x equals 0. So x equals 0 is the location of a, concave down, a relative max. And I have to think about that. I have to go, concave down looks like this. Well, then I see a relative maximum. All right, let's find the other one. F double prime at 3. Put a 3 in here. 12 times 3 minus 18. 36 minus 18 is 18. Positive. That means that f is concave up. And there is a relative minimum at x equals 3. It did not ask you for the value of the maxima or minima. It only asked you to find the location. The location is x values. All right, let's look at this next one. Let's find the points of inflection for f of x equals tangent x. All right, now, points of inflection. So we are looking at second derivative. F prime of x. The derivative of tangent is secant squared x. I'm going to rewrite it like this. Secant of x squared. So that I can see to find the second derivative here. And the second derivative is going to be 2 secant x to the first times the derivative of the secant, which is secant x tangent x. And we have 2 secant squared x tangent x. Points of inflection, we are interested where that second derivative is 0, undefined, or does not exist. So I would absolutely rearrange this a bit and write this as 2 times 1 over cosine squared x times a sine x over cosine x. And then cleaning that up still, 2 sine x over cosine cubed x. All right, now find where the f double prime is equal to 0. F double prime of x undefined. F double prime of x does not exist. All right, none here. F double prime equal to 0. That's going to be where does sine x equals 0. And let's think about the unit circle. Where does sine equal 0? That's going to be at 0, pi, 2 pi, 3 pi, 4 pi, etc. So this is going to occur when x is equal to some integer k times pi. All right. These are possible points of inflection. Looking where this second derivative is undefined, that's going to be where the denominator is equal to 0, and that will occur when cosine x is equal to 0. When is cosine equal to 0? That's up here at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, exactly. It is the pi over 2's plus k pi. So it started at pi over 2, and then the next one is pi after that. So plus k pi. All right, now these look like possible points of inflection, but they are really not. These are not points of inflection because these values are not defined in the original function. Tangent is undefined at pi over 2, 3 pi over 2, 5 pi over 2, etc. So while these are where the second derivative is undefined, they are not possible points of inflection because they are not in the domain of f of x. Remember, possible points of inflection where the graph changes concavity. If there's no point plotted there, it can't possibly be a point of inflection. All right, so really all we have is this, k times pi, and we need to set up a super chart here. And this gets just a tad bit confusing because that's an infinite number of possible points of inflection. But we do know that tangent repeats itself every pi. So if we look at one interval of length pi, find the points of inflection there, and then we know there's going to be a point of inflection every pi after that. So let's put x equals pi, one of these points of possible points of inflection, right in the middle, and then let's go pi over 2 on either side. So let's go from pi over 2 up to pi, and then from pi up to 3 pi over 2. So in its entirety, we have a length of pi, from pi over 2 all the way up to 3 pi over 2. All right. So our columns, x, f of x, f prime of x, f double prime, and description of f of x. All right, at pi, the second derivative at pi, well, it became a possible point of inflection because that's where the second derivative was 0. So that's 0. All right, now think unit circle. if we have a value between pi over 2 and pi that's in the second quadrant. In the second quadrant, is sine positive or negative? In the second quadrant, sine is positive. In the second quadrant, cosine is negative. Cubed is negative. So we have a positive divided by a negative. Overall is negative. If we look from pi to 3 pi over 2, pi to 3 pi over 2 is in the third quadrant. The sine in the third quadrant is negative. Cosine in the third quadrant is negative. So overall, this is positive. That means that f of x is concave down here and concave up on that interval. All right, now we've got the change in concavity. We need to check for a tangent line. So let's look at f prime, and we'll evaluate f prime at pi. All right, here's f prime. Let's evaluate f prime at pi. That's going to be the secant of pi squared. The secant of pi is negative 1. Negative 1 squared is 1. So f prime at pi is 1. All right, do we have a tangent line? Yes, we do, because that's the slope of the tangent. That's the slope. So this is a point of inflection. All right. Last bit here, since I asked you to find the points of inflection, we will need to find this y value here and plug in pi into the original, and that will give us a 0 here. So our answer, the points of inflection are, the x coordinate is k pi. Remember, we just did one of them, and we know they're going to occur every pi units after that, so k pi, comma, 0.